So the question of the day is, do solderless wire connectors actually work? Now, back in the day, a long time ago, when you wanted to put two wires together, you had a couple of options. You could just twist them together and tape them, and that would work, but it probably wasn't the best connection. But if you really wanted a solid connection, you would use something like this. Now, this is a butt connector. Butt connectors work pretty well. This is an insulated butt connector because it has a piece of plastic around it. And you would basically put your wire down in the end, and you would take a tool, kind of like this, and then you would just crimp it together, and friction would hold your wire in there. And it actually did a pretty good job. It wasn't a bad thing. We would tape them up and do other things. And then along came heat shrink, and heat shrink's pretty cool. What it does is when you heat it up, it shrinks. That's why they call it heat shrink. For really fancy, you would basically set your wires up like so. You would put them inside the butt connector, and you'd put them down in there. You would take your crimpers, you would give it a nice good crimp, like so. Okay, and then friction alone would hold your wires in, and you would take some of this heat shrink and tuck it across and center it up and turn some heat on. This is a heat gun, just basically a glorified hairdryer. And you can see with the heat, this heat shrink will seal up your wire. Well, that worked pretty well. It wasn't a bad idea. It worked pretty good. But then as technology kind of advanced and things got a little bit better, they ended up developing butt connectors with the heat shrink already on it, like this one here. Now these are pretty cool because basically they have the heat shrink built on, but they also have something else. They have a little coat of glue on the inside. So after you crimp them and you heat them up, they become really sealed watertight. So they're great for boats and things that are outdoors and even cars under the hood and things because it pretty much keeps them pretty dry, but you still have a friction hold. So the pinch of the metal that's inside the sleeve here is what keeps your wires from coming apart. You do have an added bonus though, the heat shrink here, since it has a little bit of glue in it, it not only keeps the moisture out, but it also helps keep the wires from tugging. So you can see here, we're just going to melt it on down. Now, I always thought these were really cool. These were kind of, you know, the Cadillac of butt connectors. Now, you can also melt this with a match or a lighter. I just prefer a heat gun because the heat gun gets only so hot and you don't burn them up. So there we go. It's nice and sealed on that end. You can see how it kind of changed color. And this end is nice and sealed. And that is a really good connection, other than you are held by friction with this pinched piece of metal down inside. Now that brings us to these guys. Now these have been advertised recently pretty much anywhere on the internet, and they're basically called solderless wire connectors. Now I don't know why they call them solderless wire connectors, because technically there is a little bit of solder inside, and we'll get to that. They really should call them no crimp wire connectors. Theoretically though, they work pretty well, and we'll talk about why. Now the first thing you're going to notice is they have bands on them. Each band would indicate a different size wire, just like a standard type wire connector, or in this case these are all butt connectors. But I do want to show a little bit of a close-up on this bigger one here, and you can see that basically there is a little bit of solder right in the center. That's a solder ring. Now something else on these particular connectors is these color bands not only dictate what size wires these are used for, but they also are a little bit of glue. They seal up the wire after you shrink them on. So you do use a heat gun with these, or a lighter or a match, but you have to get this ring hot enough to melt. Now it's a low temperature solder, and the trick is, which had to be an engineering marvel, is the solder actually melts at a temperature apparently lower than the actual heat shrink does. So the heat shrink can technically get hotter than the solder, and the whole thing won't fall apart on you. So I want to try one of these today to see if these actually do work. Now what the instructions tell you to do is basically tuck it on the wire like that, and instead of putting a piece of wire in one end and a piece of wire in the other, you're supposed to kind of intermingle them like this. I said like this. And kind of mesh them together and get them kind of tight. And then you slip the tube over like so, and you line it up just like that. Now we're not going to crimp it, we're going to try to melt it and see if this works. So we turn on the heat gun up here. Now I have the heat gun on high. And you can see the heat shrink is already starting to melt, which is a good sign. And you can see the color bands here on the end, they've actually started to melt as well. And I don't see any solder melting yet. Actually, I'm just starting to see it melt. And I believe it's melted. Now I am going to say the one thing that bothers me about these connectors is anybody that's done any soldering before, they kind of understand that you have to get the material that you're soldering to hot enough to melt the solder. And what I was afraid when I first seen these is that maybe when you put the heat on the whole ring here, that once you melt the solder, that the insides might not be hot enough to soak in the solder. So the copper wires have to be hot enough to melt the solder. Now the bonus here is they claim that this particular solder is a very low melting temperature style of solder. Now I'm going to say that when I tug on the wires, they actually feel like they are together with solder. The glue and the heat shrink isn't really holding it together, but I'd like to cut it apart and see just how good this particular solder joint is. So I'm just going to take a regular utility knife here and just kind of cut down into it, and then we're just going to examine it to see if these things really are working or not. Now I cut some of the solder away on that. I'm going to try not to do that around the rest of it here. But so far, I'm not totally impressed. It looks like to me that we had a little bit of success on just the outer strands, and the inside never got hot enough to soak up the solder. Now this is, I'm going to take a guess, probably 10 gauge wire, so it's pretty thick wire. It might actually be 12, but it's somewhere in there. But I can definitely see that if you watch, you can see some of the strands didn't get any solder on them at all. Now I would not call this a very good solder joint, and I wouldn't be comfortable with this if it was something that I myself was wanting to last a long time. I would actually rather use a regular butt connector, a crimp style connector, as opposed to this by what we've seen. But we can give it the benefit of the doubt and say that maybe it doesn't do well with larger wires, and we can try maybe a smaller wire, and let's see what happens there. Now this is a size 22 wire. 22 gauge, and I'm using the red crimpers, which according to the box says it'll work between 18 and 22 gauge. So we're going to go ahead and try this one and see if it does maybe a better job. So we can see the heat shrink is melted. That seems to work okay. And I can already see some solder in the middle melting. Actually, the solder, I can tell you right now, is completely liquefied. And this looks like it might be a way better connection. So it could just be that my heat gun isn't quite getting hot enough with the larger wires, or maybe the heat gun is struggling to keep everything hot and everything's just kind of heat soaking away. So now you can see that the solder did melt. It actually melted really well. Looks like it's melted all the way around. The glue that's in between also sealed up the wire. So this wire looks like it would be a very functional, nicely done, nicely sealed wire that would probably work even underwater. But let's cut it apart and see what it also looks like inside. This time I'm just going to take a pair of cutters here and just cut right down the center. And then we're going to kind of peel back and take a look at the strands and see if we can see if the solder actually melted all the way to the center of the wires. And it did. You can see that even on the inside, I don't know how good my camera is going to be for you guys, but you can definitely see that it did melt all the way on the inside. So the smaller wires work really well, but the bigger wires do not seem to. And my theory on that is it's just heat sinking the heat away before you can get the actual copper hot enough for the solder to melt. Now, as much as I was hoping for success, we just didn't get it. As you can see, as much as I keep saying this, it just didn't get hot enough to soak the solder into the copper. I really wish it worked though. I think these would be kind of pretty cool if you could pretty much simply pull off connecting two wires with nothing more than heat. It did work with the smaller wire, so maybe that's something. Maybe it only works really well with smaller wires. Or again, maybe I'm doing something wrong. So leave some comments below if you have any ideas on what might work with these. Now, as usual, take a look at some of my other videos. You might find something you yourself might want to build, or at the very least, maybe you'll be entertained, or maybe not.